Imagine being able to analyze a construction project in seconds, knowing whether everything was on track and what the big problems were. Attention gets drawn to those problems at a point in time where you can still make changes to do something about them. Well, that's exactly what the goal of construction project dashboards are, and why, on average, having effective dashboards and reporting reduces the chance of cost overruns on construction projects by around 31%. If you ever had the experience of finding out a subcontractor was 3 weeks behind schedule and nobody told you, working out you were 20% over your material budget only when the supplier invoices came in, or getting grilled in a project status meeting and trying to scramble through 12 different spreadsheets to clearly understand why, then you already know why effective reporting and dashboards are essential. The thing is, you don't need to be a data scientist or spend hours in Microsoft Power BI to build the perfect dashboard. Often, simple, effective dashboards that report the right information using the right data are the key to properly understanding what's going on in a project, where the problems are, and identifying where you should put your time and attention. So that's why in this video, we're going to talk about what is a project management dashboard and what makes them useful, what information dashboard should contain, how to collect this data and structure it in the right way. Then we're going to finish off by showing you how to build your first dashboard. Throughout the video, we'll be using the construction management software Mast to be doing this. And if you want to download the notes I'm going through in this video, then I'll put a link in the video description. So to begin with, what is a project management dashboard? Management dashboard at its core is just a snapshot of a project. At its core, it's the visual command center for a project. You can instantly look at this dashboard and you can see some basic project information, what the budget is, what financial commitments have been made, projected cost of completion. So you can already see it's going over budget. You can look at the schedule, the planned completion date, and automatically you look at the project and you get a pretty good idea of what's happening and what matters. The thing to note with the dashboard, and this comes back to my philosophy of construction data, that data is only useful if it drives decision. Reports are only useful if they drive decision. If you look at a dashboard and you do nothing with the information, then the dashboard has not had any effect. The goal of project management, reporting, data, dashboards, all these things is that people look at this, they take this information and they do something about it. Now, obviously, it's not that simple. As contractors, we're obligated to make reports. Project managers want to know what happens. Stakeholders should be informed if they're the ones financing and paying for the project. However, its core value, the value in construction data, is that it changes the way we do things so we can shape the impact of the project. If someone tells you that the project is over budget and you do nothing about it, then was that really useful information? But if someone tells you 10% of the way through the project that you're going over budget and you start to address the root cause, change the ways the work's being coordinated, find out what the root issue that's driving that overspend is and do something about it, then that information was unbelievably valuable. So what we're talking about here is really core to project management dashboards and reporting. It's the idea of a leading indicator as opposed to a lagging indicator. A lagging indicator is like looking in the rear vision mirror. It tells you what's happened in the past. Maybe costs been overrun on a package by 15%, your schedule is delayed by 3 weeks, or you've had 5 safety incidents in the past month. It's telling you what has happened previously. A leading indicator is an early warning system. It's telling you that something is about to go wrong. It's flagging something is about to go wrong before it's happening. So that there have been RFIs unanswered for 5 days could be flagging some sort of schedule delay or design issue. That there's 50 submittals, the design team, that they haven't done anything about, or we're waiting on information from the client. Again, it's flagging that something is potentially going wrong. We're going to have issues with procurement. You could look at your productivity rate for a certain activity, could be 25% of the way through and you're achieving 75% with the planned productivity. Again, you can clearly see that we're going to overspend on that package and we're identifying this at the 25% point of the work. Still 75% of the work left to do, that we can address it and do something about it. So I guess the key thing I'm trying to say by introducing this idea of dashboards is you should always have at the forefront of your mind, putting together data, when you're putting together reports, is what decisions is this information going to drive? How is it going to shape the future of the project? Okay, so let's get more into the nitty-gritty of dashboards and what information should dashboards contain. So I'm going to be demoing this with a construction management software called Mast. Now, Mast isn't specifically designed for construction contractors. It's designed as much for clients and project managers, in which case there isn't a lot of detail about tracking productivity rates, labor hours, or quality and completions, which would be more designed for a construction contractor. However, it's an incredibly easy and intuitive, simple construction management dashboard software where, again, you don't have to spend hours putting spreadsheets together or building a complex Power BI dashboard. You can pretty much get started in seconds. So the essential project management dashboard that every construction project should contain should report on cost, so how much you're spending versus how much you plan to spend, where and how you're overspending, safety and risks, incidents and near misses, what could potentially go wrong, what could go wrong in the future, the timeline, the schedule, what's your planned completion date, what's your baseline schedule, what are you actually achieving, where's the discrepancies, and general project information. Construction contractors specifically should also track quality and completions. Again, quality is a really important one to track because it's something that's often not thought about till the end of the job. So very early on, you're about to see in the project that your quality is behind and that you need to do something about it. Safety, again, is essential. Resource management, labor, productivity, utilization, equipment tracking, document control, your RFIs, when are they raised, when are they getting approved, when are they getting submitted. RFI management is a great lead indicator for future problems, and procurement. So what packages are there? Have they been let? Have they been awarded? Now, when you're talking about the contents and structure of the dashboard, again, because every construction project is different and unique, the dashboard needs to be different and unique to the project requirements. And I like this little diagram of leverage and someone trying to move a lever because essential to building a good dashboard is fundamentally understanding what is actually driving project performance. If you have a project that involves 20 kilometers of trenching, the trenching productivity rate, the amount of meters you're doing per week, is probably the most important metric for overall project performance. If you have a complex multi-trade building fit out commercial construction project, 30 different trades, then you probably don't have one single productivity metric or one single activity that's going to determine overall project performance. Probably much more important to track every individual trade. Have you let the packages on time? What percentage of the way through the spend are you? What sort of variations are you coming across? That's probably what's going to determine the health of the project. Next question I'd ask is, who's actually the one reviewing your dashboard? Is it your project team that you're trying to demonstrate and track their performance? And they probably don't need a whole lot of background information on the project because they're working on it. Is it for senior management who are looking over 20 or 30 projects? Well, then yes, you probably need a high-level summary of the project and key bits of information. You really need to understand when preparing a dashboard is tailoring it to the audience who's going to be reviewing it. Again, same as I said before, when you're creating a dashboard, you should always have at the front of your mind, what do you actually have control over? What is the key information that, if you could change, would improve project performance? Okay, let's start off by going through the first core component of your dashboard, which should be all your cost information. How much are you spending versus how much did you plan to spend? The key metrics you want to track and show on your dashboard will be your budget structure, so the original baseline budget, what you forecast to deliver the project, any approved adjustments to that budget, so you got additional funding or additional contingency was released, the current budget, which will be a combination of the original plus the approved changes, plus any contingency allocation reserves. Now, again, if you're a project team that is largely outsourcing the scope of works, you track all your subcontract values. So this would be the contract values, any committed costs, any variations you have, and what you've paid in versus paid out. You can, with your budget, you can have different cost categories. So you could have different cost codes for different portions of your budget. Say, for example, a building, you might have a cost code for site preparation, earthworks, foundations, structure, fit out, so on and so forth. And you'd also typically have some sort of cost package for preliminaries and overhead costs, so breaking out direct and indirect costs. In addition to this, against each of those budgets, you might have a specific risk provision within the budget in addition to the overall contingency you have for the project. And finally, you'd show on your dashboard any forecasts you have. So your forecast cost to complete for every individual budget, but also your forecast cost to complete for the overall project. So Key metrics will be your budget structure, contract management, any cost categories, any breakdowns of your budget, and your forecast. So what are the ways we can visualize and show this information? First one, simplest chart is simply a budget to forecast cost to completion chart similar to this, where you can see your original budget, your forecast cost to completion, and then your variance will be the difference between what you think you're going to spend delivering the project versus what your original budget was, which is your variance. So in this situation, we can see the project is going to be over budget by about $235,000. The other thing you'll probably want to show is your payment progress. So how much of the contract value have you actually spent and paid out? The next sort of information you want to show would be cash flow charts and tracking your monthly spending. So cash flow, again, cash is king on construction projects, tight margins, strict payment terms. We always want to manage our cash flow. It's essential to successfully managing any construction project. The typical way that you see this presented on a construction project is referred to as an S-curve, which shows your cumulative plan versus actual spend and tracks your monthly outgoing cash flow. So this is a very simple S-curve here. What it shows is at the start of the project, you're generally spending very small amounts of money. As you ramp up through construction, there's a lot of people on site. Your subcontractors are doing the work. It'll get much steeper where you're spending a lot, and then it'll taper off towards the end where you're spending less and less. So the standard way to represent cash flow on a construction project is referred to as an S-curve, which is a cumulative cash flow diagram. You can also show on there monthly cash flows as well as forecast completion lines. We can also show our subcontractors, a breakdown of the subcontractors, what percent we've paid out against their original contract value, what value of variations we've had, which again is critical because if you see subcontractors that have a large proportion of variations compared to the original project scope, it's a very easy and quick indicator where you can see that that package of works is having significant problems. Okay, so how do we actually collect this cost data that's going to go into our dashboard? Well, it starts with setting up cost codes that align with our budget. We have our budget, which is basically a bucket of money to complete the project scope. We then want to break that down into cost codes or sub-budgets. So a cost code for building might be something like earthworks, foundations, structure, fit out, so on and so forth. So we have different cost codes for all these activities. Then against each of these cost codes, we want to track committed costs. So for example, say we have budget for our earthworks. Within that, we'd have a commitment to our earthworks subcontractor to complete the earthworks scope of works. We then track any actual costs we're spending against this budget. So for example, that subcontractor, they'll submit a monthly payment claim drawing down against their contract, or there might be some change to scope where they issue us with a variation. So those would be actual costs incurred against this commitment. Then each month, we'd reconcile our actual costs against the budget. We'd reforecast the cost to complete for that package. So that's how we get our original budget, our actual costs incurred, and our forecast cost to complete. For each of our subcontractors, we're really going to be tracking the original contract value that we signed a contract for, the original commitment we've made, any progress claims they're making money, how much we're spending, what sort of variations they're putting in, whether the variations are being tracked, approved, so on and so forth, and also any payment certificates and retention held. So that'll give us a really good understanding of both our actual budget position, so where we are in terms of our original planned costs versus our actual costs versus our forecast costs, but also where we are in terms of a cash position, which is going to be more about the payment claims, the retention, and so on and so forth. And within this system, we should integrate some sort of financial control. So for example, for financial commitments, signing a contract, we should track whether those have been approved by the relevant levels of management authority. Change orders, again, have been reviewed, approved, negotiated, processed. And basically, we want to track any of our commitments and that they've been appropriately approved. To actually record this data, you can integrate your accounting or invoicing systems, or you could just manually track it with spreadsheets or in a software like Mast. Okay, so here is a sample project dashboard. We can see that we've got an original budget of $2.1 million. We've got commitments to date of $1.8 million. That means with our suppliers and subcontractors, we've signed contracts of a value of $1.8 million. We've got a forecast cost to complete of $2.4 million. So we think to complete the project from where we are now, we're going to need to spend $2.4 million, which is resulting in a budget variance of $235,000. On top of this, in terms of our current cash position, we can see that we've paid to our vendors $782,000. That's what we've actually spent so far, even though we've signed contracts of a total value of $1.8 million. So we can clearly see that this project has financial challenges and it's likely going to go over budget. And another way we can visualize this is with a budget versus forecast cost to complete, which is referred to as a waterfall or bar chart, where you can see the budget, the final cost to complete, the variance, and what we spent today. So it's just another way of presenting the same information. We want to drill down and look at cost in more detail. We can look at our monthly payment outgoings and where they're tracking cumulatively. So how much we're spending cumulatively up to that $780,000. So that's the type of information we'd want to present in a dashboard. Let's look at how you would actually structure and collect this data. Okay, so the concepts we need to understand when we're talking about tracking and managing costs on a project is we have a budget, a bucket of money to deliver the project. We have contracts, which are committed costs, the supply chains. We have variations to these contracts. So that's when contract value for our subcontractor is adjusted because the works have changed. We've got forecast, what we think we're going to need to spend to deliver the works. We have payments, so outgoing payments to subcontractors or vendors, which we're going to relate to the contract that we've signed. We're also going to have cash flow, so an overall summary of what we're spending each month. Okay, so let's understand this breakdown in a little bit more detail. The first component of our cost structure, our budget. Budget is a bucket of money we have to spend to do a certain activity. People confuse budgets and estimates, but an estimate is a calculation of the cost it's going to take to complete the project. A budget is a structured breakdown of how much money we have available to spend to deliver the project. So budgets should be broken down into related sets of expenditures. If we're going to buy a whole lot of materials, we should have a materials budget. If we're going to have set subcontractors for different trades, we could ideally have a separate budget per subcontractor. Now, when we look at what a budget should contain, it should contain an original amount. So when we first initiated the project, the baseline of the project, what our original assumption for that amount of expenditure was going to be. We can have adjustments. So as the project progresses, we may need to change the budget. If new things come up, we release contingencies. Our client has agreed to pay us more money for different tasks, which leads us to having a current budget, which is the sum of the original and the adjustments. Then we have of that budget, there will be allocated expenses and unallocated expenses. So an allocated expense would be when we sign a subcontractor. So we have an earthworks budget, we sign a contract with a subcontractor of a certain value. That value that we've committed to them would be a committed budget. Unallocated budget is where we haven't yet planned exactly what we're going to do with that money. So within our committed funds for budget, we'll have contracts with suppliers, vendors, subcontractors that are going to be doing the work on our behalf. So if we think about it, we have a budget for earthworks. Within that, we have an earthworks subcontractor. If we look at this example, we have a single budget for all the construction works. And within that total budget for construction works, we have a series of subcontractors. So when we're talking about a contract, that's something we sign with an external vendor where they're agreeing to do works for us, and in exchange, we're agreeing to pay them a certain amount. So that certain amount we're agreeing to pay them is the original contract value. We issue a tender, they give us quotes, we select a subcontractor who says, yep, I can do all the demolition works as you've prescribed it for $300,000. Now, during the course of the project, that value is certainly going to be likely to change, which is where we get variation. So we get them to do additional demolition. They said they weren't going to do any removal of asbestos, but there was asbestos on site. We'd have to pay them a variation to do that work. So that would be where we adjust the value of the contract. So within our variations, we would track that per construction contractor. So for each of our contractor, they'll probably have several variations. We'd have the vendor, the variation number, category, what drove it, and the variation amount, and any adjustments to their schedule. So if we go back to our overall structure of our costs, we can see we've got our construction budget, this contracts we've signed to do those separate works, any variation values, the current contract value, which is going to be the sum of the original contract value plus any approved variations. So the next part of our overall cost structure is our forecast costs to complete. So budget tells us how much we had originally. Contracts is all about how much is let. Now we need to make a prediction of what we're going to spend to finish the project which is where our forecasts come in. Ideally, you do a forecast per budget. So you look at each of your individual budgets, monthly or on some recurring time interval, you make a prediction as to what the final forecast for that package will be. The super lazy way to do that is just to look at your current contract value. The accurate way to do that is to forecast and plan for any upcoming variations and changes, and within that package budget, have a realistic expectation of what it's going to take or what it's going to cost to finish that package of work. You do that for every single one of your budgets. As a sum, you'll get the total forecast cost to complete for the project, which again is that critical indicator on the dashboard of what you think you're going to spend to complete the project. And the final component of our overall cost structure is our cash position. So how much we're actually spending month by month, what we're paying to our vendors, which again is looking at a combination of the payment claims we're receiving from our vendors, but also if we sum that in the aggregate, then we get a total cost position of the project. Each month from our subcontractors, while they're on site and doing work, we'll receive payment claims. When we look at all the payment claims we've received from the 3 or 4, 5, 6, whatever subcontractors working on site, we sum those together, we get our total cash outgoings for a certain month, and we can look at and we can sum that over time to get our cumulative total cash outgoings. So to briefly summarize, when we're talking about our cost structure, showing information on the dashboard, what do we care about? We care about budget, our plan of what we were going to spend to deliver the project. We care about our commitments and our contracts, what we signed contracts for. We then have a forecast, which tells us what we think we're going to spend to deliver the project. And we finally have our cash position, what we're actually spending month by month, what's going out of our bank account. Okay, next up, we've got risk management, which I like to think of as managing the uncertainty that matters. Construction projects are inherently risky. We don't know the exact ground conditions. We don't know whether it's going to be contaminated soil. We don't know how many days it's going to rain throughout the execution of the project. We don't know if a key subcontractor is going to go broke midway through the project. A ton of things can happen that we just can't possibly predict at the outset of the project. Risk management is the entire discipline, the entire project management knowledge area we apply to try and manage and predict and control this uncertainty. And basically the goal of risk management is we want to increase the chances of positive events occurring. We want to decrease the chances and impact of negative events occurring. So what are the components of risk management? Well, first, the most obvious one is we've got our actual risks. These are the uncertain events or conditions, things that can or cannot happen that have an impact on the outcomes of the project. Classic risk is inclement weather. We don't know exactly how much it's going to rain. There's a level of uncertainty around that. And if it does rain, it will impact the outcome of the project. Take for another example, if it's going to rain in Greenland tomorrow, well, yes, that's an uncertain event. But if it did or didn't, it wouldn't impact the outcome of the project unless our project is in Greenland. So our risks are any uncertain events or conditions that have a potential impact on the project. If we already know something's gone wrong, for example, we've had a safety incident, that's a problem, not a risk. It has happened, there's no uncertainty about it, and it's got a negative impact on the project. So what are the components of risk management? Well, first up, we've got our probability and impact matrix. Every risk has two components. It's got the probability, it may or may not happen, and the impact, if it does happen, what is the impact on the project? We use a probability and impact matrix specific to our project to standardize the risk. So for impact, we can go from negligible to severe. From likelihood, we can go to very unlikely to very likely. We've also got our categories of risk. So we can group certain types of uncertainties under common headings like environmental risks, safety risks, financial risks, delivery risks, or so on and so forth, specific to our project. Then we've got the actual components of our risk. So for each of our risks, we'll have a risk ID, we'll have a status, whether it's active, closed, monitoring, description, our pre-rating, so our rating without any sort of treatment applied to it, and then our post-rating, once we've determined some sort of treatment or mitigation, what is the residual impact of that risk? So those are our risk management components. How can we actually then visualize and display these on a dashboard? Well, the first one, we've got a risk heat maps, which are simply grids where we display all the different risks, very similar to a risk category matrix. We can display our risks by category, so we can look at the different categories of risks and show a different number of each types of risk. We can do this by absolute number of risk. We can look at the residual treatment value, so what's the dollar value of the risk, or you can actually combine probability and impact. So if you multiply the probability of the risk by the impact if it does occur, you can get a weighted average dollar value of the risk per category if you're talking purely about financial impacts. We can have a risk register table, so we can create a table like this with all our risks ranked. Probably you'd want the most important risks at the top and the smaller ones down the bottom. We can show risk trends analysis where we display the risk score of the overall project over time, so some weighted average dollar cost of the risk on the project, or we could just give a total risk category. So lots of different ways you can display it. Ideally, the whole purpose of this is you want to draw people's attention to what are the critical risks. How do we then collect and get our risk data? The first, most obvious one is just having regular risk workshops where we go through the risk assessment process. The risk assessment process is very simple. We brainstorm to identify the risks. What are the uncertain events and conditions that can impact our projects? We create our risk library, so a register, very similar to this, of all the potential risks grouped into our risk categories. We identify risk owners, so we need to allocate the responsibility to put in place mitigations for risk. We identify the controls to reduce the risk, which gives us our post-treatment value. So what can we do to reduce the probability and impact? And then we revisit annually, monthly, or on some predefined time sequence. So fundamentally, risk management is essential because uncertainty is a part of life in construction. Every project is different, every project is unique, and every project has specific uncertainty that can impact performance. Can't control everything, but if we follow the risk management process, we can do things to mitigate the level of uncertainty, to reduce the impact of negative threats and increase the probability of opportunity. So let's now look at how we would present and display this on our project dashboard. So we can see on the key project dashboard, all we're showing are our key risk categories and the number of risks in them. If we go into what data you should actually be tracking and what you should be showing in your risk register, well, first up, you've simply got your risk categories, and under your risk categories, you've got your specific risks. So here we've got risk categories for design changes, weather conditions, safety incidents, and contamination. And within these, we've got our specific risks. These are the specific events or conditions that we need to plan, prepare for, and mitigate. So if we look under the risk of weather conditions, we have specific risk, which is construction delays. The description of this risk is delays in construction and potential damage to materials if we get unfortunate weather. Then we need to give it a pre-treatment rating. So if we do nothing to mitigate this risk, put in place no controls, we don't try to transfer it to anyone else or do anything, this is what would happen. So the likelihood is very likely, the impact is major. So again, you'd need to scale these specific to your project. So typically on your own project, you'd have an assessment of what a severe risk looks like versus an insignificant risk, typically expressed in dollars. Likelihood, again, you'd have some sort of range that you use for your project. Against each risk, we can apply a treatment. So treatment is something we decide to do. It's a threat to reduce the likelihood of occurring or the impact if it does occur. So for example, weather, you can't actually reduce the likelihood of it raining. There's nothing you can do about it. All you can do is affect the impact if it does occur. So for example, if you have weather, which is very likely to occur and has a major impact, we can't do anything to change the likelihood, but what we can do is reduce the impact if it occurs. So for example, a treatment could be for all our subcontractors, we could get them to sign up to be responsible for inclement weather if it does occur for both any delays and then rectification works for it. So we've transferred that risk to them. We're still liable to some degree if a subcontractor goes broke, or for overall delays to the schedule, maybe changes to the contractor's start dates. That's not necessarily going to be transferred. So there is still some residual impact, but we've drastically reduced the impact if it does occur. And when we talk about impact, we talk about both the cost and time. Again, for financial risks, we might also have some sort of measure in terms of safety, where you have minor risk could be small injuries, when major or severe risk could be somebody getting seriously hurt. Okay, so we go through our risk assessment workshop, we note down all our risks, and then we can look at different ways to visualize and display it. So these are expressing the risks as a heat map, looking at pre-treatment, post-treatment. So this is a matrix display. We can look at the total within the different categories. We can look at any provisions or contingency we have to hold. We can look at the cost of different risks within different categories. We can look at the risks expressed in terms of time. So what's the time impact if these risks occur? And then we just have a simple table where we can look at all our different risks with key bits of information. So those are some different ways we could choose to display risk in our dashboard. Schedule management, final core component of what every dashboard should have, is basically when everything happens. When are all our activities scheduled? When should they happen? When are they actually happening? What's the difference? What's our forecast finish date? So schedule management is all about time. So what are the core components of schedule? Well, we've actually got our original schedule, which is breakdown of the different phases of the project, all the activities within the phases, the durations of each of the activities, the sequencing of the activities, so what order they need to be completed in, the foundations need to be done before the structure, which needs to be done before the fit out, what's the relationship between all of these, and are there any core milestones such as separable portions in the contract or bonuses for early completion. Then we've also got our schedule metrics. So we've got the baseline schedule, which is when we originally thought, same as our budget, what we thought we'd spend. The baseline schedule is how long we thought the project would take. Then we have our actual dates we're completing tasks. We also have our forecast completion date. So what we currently think where we're going to sit. So we can compare our baseline to our actual, what's actually happening in our forecast, the same way as we did our budget assessments. We've got float and slack time. So for each of the activities, how much can that activity be delayed before it impacts our critical path? And then most importantly, we've got the critical path. What is the core sequence of activities that have zero float? What activities that if you delay them will delay project completion? And against these activities, we have our progress tracking. So we can mark off activities as they're completed, the percent complete, what upcoming activities, and if any activities have been delayed. So what are some different ways we can present and view the start? The first one would be simply a high-level summary showing different phases of the project, such as design, procurement, construction, commissioning, completions, handover, with all of the key milestones defined, any key contract dates. That would be a very high-level summary of the overall project. The other way we can view it, if we want more detail, is we can add in a Gantt chart. So a Gantt chart is simply a visual representation of different activities and as they link and connect to each other so you can see the overall sequence of the project. We could also look at a simple list of all the activities, although visually this is going to be much harder to process. It's not going to be easy to see the different activity linkages. We can use things like worm diagrams, which are longitudinal displays of activities like this, where again, it works for a simple project where you have a defined set of phases, but if you start to get complex projects, it's going to be hard to understand, define, and see things like the critical path or the core activity sequence. For longitudinal projects, so things like road projects, where there's, for example, you're building a road, you've got set change markers, for example, a 24-kilometer road, you can actually map out activities as lines, which gives you a line diagram, which is very easy to understand and quickly see which of the core activities are what's going to delay progress, or you can use something like a simple milestone timeline. So then, how do you get your scheduled data? How do you actually collect the information we need to create all these different displays? Well, first one, very simply, is you have to build your original baseline schedule where you start with the contract milestones. What's the finish date in your contract? How long do you have to do the project? Are there any early completion dates, core separable portions, any core client deliverables you're waiting for? You then break that schedule down into core phases. You detail the activities within each phase. You then estimate the durations, apply the construction logic, the methodology, sequence them correctly, add any lag and lead times, resource load them if required, and then you get your baseline schedule. Once you've developed your baseline schedule, you've got your plan, how long you think it's going to take to do the project, and what's the original plan sequence. Then as you start delivering the planned works, on some iterative time frame, some recurring process, you need to track your daily, weekly, monthly actual progress, record the start dates of all the activities, what percentage complete they are, and so on and so forth. Then you'll be tracking your actual schedule performance, and then you'll also be reforecasting your completion dates. Maybe you've got some error in your original baseline schedule and you missed the dependency or lag. You constantly should be updating your original project schedule to maintain both current project schedule used to coordinate and manage the works, but also to keep forecasting out your completion date and ensuring you're not going to violate any core contractual dates. How can we then build this information into a dashboard that our managers and client representatives can see? Well, the first thing we should always have on our dashboard is our planned completion date. When are we actually planning to finish the work? At the end of the day, that's what anybody cares about. If we have important separable portions, another important thing to show. The next thing we can show is some sort of overall timeline. So if we have space, we could do that as a Gantt chart, or here you can see we've done it as a worm chart where we've just got each of the individual project milestones, whether it's complete, whether it's ongoing. Again, this works for a simple project where it has a linear set of tasks, but if there's complex interdependencies, someone's going to miss it. Next up, let's go into the actual schedule tab and just play with some different ways of demonstrating the scheduled data. Again, you don't have to use Mast. You can do this in Excel or any tool, but it just gives you a good overview of the type of data we're collecting and different ways to display it. Building blocks of any schedule, any project program are the activities. And so an activity is simply a task that has to be done in the project. So it'll have a start date, a baseline start date, a baseline finish date. So at the start of the project, when we were planning it, when did we think it would start? When did we think it would finish? And then we'll also have an actual start date and an actual finish date. So what date did the activity actually start? What date did it actually finish? We've also got phases. So a phase is simply a group of related activities. So for example, within the feasibility phase of this project, we've got the project kickoff meeting, the assessment, and the development of the project charter. During the planning and design phase, we've got the concept design, the detail design, the approvals, and the beginning of the procurement. And then we've also got our milestones. So the big milestone, any construction project, is going to be the completion date. As a construction contractor, this is the date in your contract, and it's the date the liquidated damages kick in. So it's an incredibly important date. You might have several portions, so where you have multiple different finish dates but different scope need to be completed. Those can be displayed. You also typically display the project initiation date and the access to site date. So those are the key dates in any construction project that should be displayed on the schedule. Now, how can we display this information? Well, we can show it simply as a set of activities like this. We can show it as a Gantt chart, which is what we typically think of when we think of a construction project schedule, which is bar charts where the tasks are related, which we show drop-down lines. You can't do it in Mast, but if you're using Microsoft Project or Primavera P6, you can highlight and display the critical path as well. The critical path being a sequence of activities. If delayed, delay project completion. We can have a worm chart where we're simply showing the activities longitudinally, which activities are done, which are in progress, and display any delays. So that's where you get a difference between the baseline completion date and the actual completion date. That'll show as a delay, or again in the schedule where if we're ahead of our baseline, or we can simply show the key phases of the project. Again, this project just has 4 phases, which is feasibility, planning and design, construction, and closeout. Okay, just to briefly wrap up, we covered 3 things. We covered cost management and how to display whether you're accurately tracking against your budgets and how you're performing financially. We spoke about risk management, how to display the uncertainty that matters and to demonstrate that you're both tracking and managing risk properly. Finally, we spoke about schedule management. Are we completing all of the activities in the correct order on time? To wrap up, what are some best practices about dashboards? Number 1, as I said in the start, is data is only useful if it drives decisions. So we always have to ask ourselves, what are the key leverage points of the project? What is the data that actually matters? What is the data that's going to change the outcome of the project? Because that's the data that matters. Second question you need to ask yourself is, do you have control over it? Yes, you can track things like inclement weather, but they're largely outside of our control, so not necessarily something that we can influence. So the second thing you want to look at when you're talking about data is it something you can have control over? Is it something you're actively able to manage? The third essential part of dashboards and managing data is you should always be tracking lead indicators. A lead indicator is something that predicts whether something is going to go wrong in the future. For example, are we getting our RFIs closed out on time? Have all our procurement shop drawings been submitted on time? What we're doing with this is we're tracking things that are going to cause issues later on down the track, and we're presenting and recording data that has the potential to change the outcomes of the project. We're not driving looking in the rear view mirror, we're driving looking through the windscreen. Finally, as always, simple is better than complex. You can create a dashboard simply, express something simply. It's always going to be much easier to interpret and much easier to use. And just quickly, if you liked this video, we've got another video that I'll put a link for after the video where we cover the fundamentals of project management for construction professionals in much more detail. So if you want to go into more detail on topics like cost, schedule, risk management, then watch this video next.